The much-hyped FigureAI is headed to work for real. We also have brand new details about when the advanced AI robot will be available for the home, and how much it'll cost. Stick around for more, including 1X Tech's plans for deploying its Neo robot in homes, a Jetsons-inspired robot, a thinking humanoid from Germany, new AI tech inspired by the Dung Beetle, a French open-source humanoid, a robot with lab-grown brains, a throwback humanoid, and more. The FigureAI is returning to work for BMW on a permanent basis. Several of the advanced humanoid robots will start working at the luxury automaker's Spartanburg, South Carolina plant in January after a successful pilot. The open AI-backed startup revealed the news when TechCrunch visited its Sunnydale headquarters. The initial fleet will be more than 5 robots. During its recent trial, the FigureAI successfully inserted sheet metal parts, which requires considerable dexterity that could not previously be achieved with robots. Figure founder Brett Adcock told TechCrunch the robots worked nearly 24 hours, 7 days a week during the trial run. The company has much bigger plans for the FigureAI beyond automotive assembly. Figure plans to expand to a nearby facility as it scales production of the robots. During a recent podcast, Adcock told futurist Peter Diamandis domesticated robots are up next.
Give me a guess. Is it 3 years, 5 years, 8 years?
I would say within the next 3 years, we'll definitely have robots piloting homes. Yeah.
Nice. Okay, I want to volunteer early on.
Yeah.
I'll pay.
Yeah, we'll probably start with some mock homes here in our facilities and start, getting the bugs worked out, understanding how the system architectures all work. But I'm interested in seeing what problems we face that we're not prepared for that are limiting our ability to get in the home long term as well.
Figure calls the FigureAI the most advanced and first commercially viable, autonomous humanoid robot on the planet. Adcock believes the robot could eventually cost about $20,000, which is the same price point Tesla and 1X are targeting with the Optimus and Neo. The FigureAI has tripled the computing power of its predecessor, the FigureAI. Standing about 1.7 meters, the second iteration has 6 cameras to see and understand its surroundings. It talks to people using built-in microphones and speakers. Its human-like hands can carry up to 55 pounds. Its foot design is more human-like, suitable for a sneaker fitting. Its battery runs for 5 hours, a 50% improvement. According to NVIDIA's blog, FigureAI accelerated the robot's development using Isaac Sim, a reference application built on the Omniverse platform. The synthetic data was used to design, train, and test the robot. NVIDIA said a second RTX GPU on board makes the robot 3 times better at performing AI tasks on its own compared to the original. When the much-anticipated 1X Neo humanoid robot enters homes, it'll rely on human operators to start. The OpenAI-backed startup says the logistics of training robots for autonomous tasks in homes is one of the biggest challenges going to market. 1X shared its plans with S3.
The way we're going to tackle this problem is basically by having human teleoperation be a stand-in for the autonomy on day one. So it'll still be useful to do chores in your house, but this is fulfilled by a human operator who's remotely controlling the robot. And you can imagine that over time, as the AI gets better and better, we're replacing small parts of the workflow of the tasks and chores with AI. Kind of like the ship of Theseus, right? Where you swap out one plank at a time, and then eventually it's a completely new ship that's powered by AI rather than humans.
1X Technologies gave S3 an exclusive look inside its facility where it's developing its next-generation humanoid robot for home use. X1's first robot, Eve, reached a peak production of 10 to 20 units per month. For its new robot, founder and CEO Bernd Brnich wants to scale up to 5 to 10 times that amount in a new factory currently under construction.
A few years from now, the robots that you have at home, whenever they don't have anything to do, they're working on whatever they're bad at.
They're doing science.
They're working on whatever they're bad at, right?
Standing 5'4", the robot weighs just 66 pounds, which 1X says makes it safe for use in households. It can run 7.5 miles per hour. At that speed, the robot would finish a 5K race in just under 25 minutes, which is well above average for human runners. It walks at a pace of 2.5 miles per hour. The Neo can carry up to 44 pounds, or about what a medium-sized microwave oven weighs. In a press release, 1X touted the robot's Bio-Inspired design as a game-changing safety feature. The robot has a soft outer covering like a padded suit to keep people safe if it bumps into them. The Neo-Beta robot's motors use cords to pull and move smoothly, like human muscles. There are no pinch points for safe use around children and pets. Neo also learns like a human through teleoperation. Humans control it with VR headsets while it's learning. It watches and practices until it learns how to do tasks like cooking, cleaning, or playing games as it's controlled through a VR headset. Neo-Beta is different from high-profile humanoid robots inching toward commercialization like the Tesla Optimus, FigureAI, Boston Dynamics Atlas, and Agility Robotics Digit, because it's designed for home use from the start. This humanoid robot is designed to make life more like the Jetsons. That's according to Weave, a California startup that's taking pre-orders for its Isaac robot. Isaac can fold laundry, feed pets, and automatically clean rooms. It's controlled by an app and responds to voice and text commands. It has a camera that hides away when not needed for privacy. The cost is $59,000 or $13.85 monthly. Reservations are $1,000. First deliveries are set for fall 2025 for 30 customers in the US. This humanoid robot has cognitive abilities, and it's coming to a neighborhood near you soon. That's according to Neura Robotics, the German company that developed the For Anyone AI robot. In new footage, the humanoid robot, standing 180 centimeters or about 5'11", is shown ironing, doing laundry, watering a plant, and serving a cocktail. Neura Robotics says the For Anyone robot can see, hear, and touch with its advanced sensors and AI. It has a touchless human detection sensor for safe interaction with people in different environments. The robot's forearms can be exchanged to suit different tasks, making it versatile for different applications. Besides the For Anyone, Neura's product lineup includes the Lara series cobots and Maria, which the company calls the first commercially available cognitive robot. Do dung beetles hold the key to big technological breakthroughs? Predating humans by about 128 million years, they navigate at night using advanced capabilities scientists only discovered a decade ago. Instead of the moon, they use the Milky Way's band of stars to help them move in a straight line at night. Now, researchers from the University of South Australia have developed an AI sensor that recreates the beetle's navigation. They program cameras to detect the Milky Way to help drones navigate like dung beetles do. The sensor replicates how the dung beetles sense the starry band with their compound eyes. They use computer vision to detect the Milky Way's position, even in low light and with motion blur. The AI sensor could help drones, robots, and satellites navigate in the dark. This would be especially useful for space missions and rescue robots in tough environments. It could also be a reliable backup for navigation if other systems fail. This is Ricci 2, an open-source humanoid robot for exploring robotics and AI. French startup Pollen Robotics plans to release the AI-ready robot in October. It will be available as a full robot with a mobile base and stationary with one arm. It is mainly for use in research, education, and customer service. Its arms have 7 joints, allowing for flexible movements. The robot can be controlled using virtual reality for more precise actions. The Chinese researchers who developed the brain-on-chip technology, called MetaBioC, let Shanghai Eye in its lab to capture this footage.
脑接口用的是人或者是动物真实的大脑。
The brain-computer interfaces use real human or animal brains, but our brain-on-a-chip interfaces uses a brain cultured in vitro, just like the organoid cultured in a cell culture dish in this model.
They're among the growing number of scientists around the world exploring the use of lab-grown brain cells for advanced computing. The technology could superpower AI, create smarter robots, and lead to breakthroughs in brain disease treatments. Researchers from Tianjin University and Southern University of Science and Technology say their tiny lab-grown brain, or brain organoid, could learn tasks faster than current AI models. They say it uses much less energy than AI, which needs a lot of power and data to learn. These brain cells also show more intuition and creativity than AI, learning with fewer examples. The researchers believe this technology could combine human-like and machine intelligence. This would mean robots and other machines could think and learn more like humans. The goal is to create smarter robots that learn and adapt on their own. Lab-grown brain cells in robotics and AI bring up ethical and practical concerns. A key drawback is the uncertainty of brain organoids developing consciousness over time. In 2011, China took a big step forward in humanoid robotics with the Beijing Institute's BHR-5. It was noted for its advanced manipulation and control. The robot played table tennis, exhibiting quick reflexes, precise movements, and real-time decision-making. With its stereo vision system, the BHR-5 tracked the ball's movement, predicted its trajectory, and planned its own motions accordingly. It served as a test bed for exploring complex motor skills in robotics. For a deep dive into the past, present, and future of China's humanoid robots, check the link in the description. This is a living robot. Researchers at Cornell created the Biohybrid robot that uses signals from fungi to move and respond to its surroundings. They combined fungal mycelia, which are tiny, thread-like parts of mushrooms, with mechanical hardware. The living tissue sends electrical signals that control the robot, like an animal brain controls movement. The system uses electronics to read fungi signals and convert them into robot commands. Two robots, one soft and spider-like, another with wheels, move using fungal signals, blending life with machines. These biohybrid robots could monitor soil health or detect pollution, sensing environmental cues where regular sensors might fail. Fungi survive harsh conditions and detect changes, making them ideal for robots in unpredictable environments. Remember to subscribe to stay hip on the latest in humanoid robotics. Leave suggestions for humanoid robots to include in future roundups in the comments.